lecture, I'm going to verify that y equal to exponential cos bx is a solution of the differential equation. So this is the differential equation we need to verify. So let's see the answer. So first here, writing the given y equal to e power x cos bx. So this is the given. Now here we need to get here dy by dx first. So doing the differentiation with respect to x. So dy by dx, and the next is d e power x cos bx divided by dx. And here you can get two terms here, u, and this is here v. So d and here uv divided by dx. So writing v doing the differentiation of u, and here writing u doing the differentiation of v. So the next is here writing the cos bx doing the differentiation of e power x, and the next is here writing e power x and doing the differentiation of cos bx. So after that, this is here e power x and cos bx, and this is now here minus that come cos bx differentiation minus sin bx, and if you want then you can include here e power x. So this is the value of dy by dx. So here e power x and sin, this one differentiation is cos bx, that is equal to minus sin bx, and the next is bx differentiation b. So after calculating this one, so this come e power x minus and here sin bx into b. So there is the b. So this is the differentiation. Now we need to get here second differentiation. So again doing the differentiation with respect to x. So d and here d e power x cos bx divided by dx, and now next is b is the constant right there, and here d e power x sin bx divided by dx. So again we need to apply like this. So first here e power x differentiation that I'm going to do. So e power x only, cos bx right, and here plus e power x write that, and doing the differentiation of cos bx. So cos bx differentiation that is equal to minus sin bx, and here bx differentiation that is b, and here write b. The next is here e power x differentiation e power x, and here sin bx. The next is here e power x write that, and sin bx that is equal to cos bx, and bx differentiation b. After that here we can write e power x cos bx, and this is now plus minus minus, and here b e power x sin bx, and the next is here minus b e power x and here sin bx, and after that minus b e power x. So this is now b square minus b b square, and the e power x cos bx. Now here you can see e power x. So this is the same terms. So this is the same terms, so that we can add this one. So this is now e power x, and here cos bx, and minus 2 b e power x sin bx, and here b square e power x cos bx. So second differentiation this one. Now here let's write this one, this all. So taking the LHS, left hand side. So left hand side d²y dx², and after that minus 2 dy by dx, minus 2 dy by dx plus 2y, minus 2 dy by dx plus 2y. So writing here this one d²y, this value e power x cos bx, minus 2 b e power x sin bx, and here b² e power x cos bx, and then after here minus 2. So this is now this terms, so minus 2 multiplying with this one, so minus 2, then after e power x cos bx, e power x cos bx, and after that here minus b e power x sin bx, minus b e power x sin bx, and after that right here y terms, so plus 2, and here this is y terms, so e power x cos bx, e power x, so no need to give the rectangle, e power x cos bx. Okay, so this is the things here. Now after doing this here, we need to simplify and try to get the output. So first here writing this one e power x cos bx minus 2 b e power x sin bx minus b² e power x cos bx, and this is now minus 2 e power x cos bx, and here plus 2 b e power x sin bx, and here 2 e power x cos bx. So this is the terms. So here 2 e power x cos bx, 2 e power x cos bx, cos bx, same term is there. Now after that here 2 b e power x, so this is here sin bx must be sin bx, b missing, so this is the same terms. Now after that here I'm getting e power x cos bx, and here e power x, and here b² cos bx. So here b² is there, and here there is no any b², so this is cannot be equal to 0. So this we can write. So here this is not equal to 0. So if that is not equal to 0, so is a solution of differential equation. So here we can write not solution, because it does not come the value 0. So this is the way we can try to get here the solution of differential equation. So first differentiation right there. Now after that here you need to create here you need to get your second differentiation, take the LHS, try to make that 0, but when that not come, then it's not a solution. So this is the way we can verify this question. So now in this video it's over. So thanks for watching, see you next video. Thank you.